So this is exam number 1. I'm going to be using the Ashton-Rigid pavement equation. It's up here, and I'm going to be using Excel. So I'm going to write down all my knowns first. We're looking for the slab thickness, so we're going to be looking for D. So then, traffic forecasting. Okay, so then our performance traffic is going to be 8 million. To the 6. And then our elastic modulus of concrete is 4 million. To the 6. Our concrete modulus of rupture is 500. Our effective modulus of subgrade reaction is 100. The subgrade material exhibits poor drainage, so that's going to be needed for our drainage coefficient. So poor drainage. And then since our reliability is 90%, let's see. Okay. So then standard deviation is 0.35. Okay, so we can know our terminal serviceability because we know that it is an interstate highway, so it's a major highway, so it's going to be 2. Okay, so now the rest of the values we can get from our textbook. So for our normal deviate for level of reliability, we have our level of reliability, so we're going to go to page 5. And our level of reliability is 90. So our standard normal deviate is 1.282. Right. So now we're going to get our drainage coefficient, which is 581. So then, our drainage coefficient, we know it's poor drainage. Okay, so we know it's poor drainage, and we're going to say that it is 5.5%. So I'm going to say like I'm going to go with 0.75 since that's kind of in the middle. Okay. And then our low transfer position is going to be on 576. Okay. Okay. So then, wait, no, this is one. Okay. So it is going to be 3.2. So then, we'll go back to it. So now what we're going to use is solver to find our. So this is going to be our objective, but it's going to be equal to 8,000. And then we're going to be changing this here. Okay, so we got it to be 0.83 inches. And so that is my answer. Thank you.